Every year, over 6 million cobia are raised in advanced aquaculture facilities across the United States, transforming from tiny fry into premium fish that command prices exceeding $25 per pound in luxury seafood markets. This remarkable fish, once considered a bycatch species rarely seen on restaurant menus, has become one of the most sought-after protein sources in high-end dining establishments from Miami to Seattle. But what makes cobia farming so revolutionary that it has attracted hundreds of millions of dollars in investment? How do these sleek, powerful fish go from controlled breeding environments to the plates of discerning diners? And why are industry experts calling cobia aquaculture the future of sustainable luxury seafood production? Welcome back to AgriCraft, where we explore the cutting-edge world of modern agriculture and innovative food production. I'm your host, and today we're taking you inside the fascinating realm of cobia farming and processing. From the sophisticated breeding programs that produce superior genetics to the state-of-the-art processing facilities that maintain restaurant-quality standards, we'll reveal every aspect of this remarkable agricultural transformation. All will be revealed in this video. Cobia farming represents one of the newest and most technologically advanced sectors in American aquaculture, a field that has revolutionized our understanding of marine fish production. The cobia, scientifically known as Rhacecentron canatum, was virtually unknown to most Americans just 2 decades ago. This powerful predatory fish, native to warm coastal waters, remained largely unexploited until researchers discovered its exceptional qualities for intensive cultivation. The transformation of cobia from an obscure marine species to a premium aquaculture product reads like a modern agricultural success story. In the wild, cobia can reach lengths of 6 feet and weights exceeding 60 pounds, making them formidable predators in their natural environment. However, their rapid growth rate, excellent feed conversion, and adaptability to captive conditions made them ideal candidates for intensive farming operations. What truly sets cobia apart in the luxury seafood market is their exceptional flesh quality and unique flavor profile. Unlike many farmed fish species, cobia maintains firm, white meat with a rich, buttery taste that chefs describe as a cross between salmon and sea bass. This distinctive quality has made cobia a favorite among celebrity chefs and fine dining establishments, where it commands premium prices that can exceed $50 per plate. The economic potential of cobia farming became apparent when early research projects demonstrated growth rates that surpassed virtually every other marine fish species in aquaculture. Juvenile cobia can gain over 2 pounds per month under optimal conditions, reaching market size of 8 to 12 pounds in less than 18 months. This rapid growth, combined with excellent feed conversion ratios, creates profit margins that have attracted significant investment from venture capital firms and agricultural corporations. The United States currently produces approximately 15 million pounds of farmed cobia annually, with facilities concentrated in Florida, Texas, California, and the Carolinas. This production represents a dramatic increase from zero commercial production just 15 years ago, demonstrating the rapid adoption of this revolutionary aquaculture technology. Industry projections suggest production will triple within the next decade as new facilities come online and existing operations expand. International competition in cobia farming has intensified dramatically, with countries like Vietnam, China, and Taiwan establishing massive production facilities. However, American cobia farmers maintain competitive advantages through superior genetics, advanced technology, and proximity to premium markets. The American cobia industry has focused on producing the highest quality product rather than competing solely on volume, positioning itself in the luxury segment where quality commands premium pricing. The journey of premium cobia begins in highly specialized breeding facilities that represent the pinnacle of aquaculture science and technology. These breeding operations start with carefully selected broodstock that have undergone years of genetic evaluation and performance testing. The selection process for cobia broodstock is incredibly rigorous, with fish evaluated for growth rate, disease resistance, feed conversion efficiency, and flesh quality characteristics. Cobia broodstock are housed in massive circular tanks that can hold up to 100,000 gallons of precisely controlled seawater. These breeding systems utilize advanced recirculating aquaculture technology that maintains perfect water quality while minimizing environmental impact. The water in these systems is continuously filtered through biological, mechanical, and chemical treatment processes that remove waste products and maintain optimal conditions for reproduction. Temperature control in cobia breeding facilities requires sophisticated heating and cooling systems that can maintain water temperatures within 1 degree of the optimal range. Cobia reproduction is highly temperature dependent, with spawning occurring only when water temperatures reach precisely 82 to 86 degrees Fahrenheit. The heating systems use heat exchangers and thermal mass systems that provide stable temperatures even during extreme weather conditions. The breeding process for cobia involves complex hormonal manipulation that synchronizes spawning events and maximizes egg production. Broodstock fish receive carefully timed hormone injections that trigger the final stages of egg and sperm development. This synchronization allows breeding technicians to predict spawning events with remarkable accuracy and ensure optimal egg collection timing. During peak breeding season, which typically runs from April through September, a single female cobia can produce over 5 million eggs per spawning event. The spawning frequency varies with water temperature and nutritional status, but peak performers can spawn every 4 to 6 days during optimal conditions. The eggs are collected using specialized skimming systems that gently remove floating eggs from the surface of breeding tanks without disturbing the adult fish. Cobia eggs are remarkably small, measuring less than 1 millimeter in diameter, and are nearly transparent when first released. The fertilization rate for properly managed cobia breeding operations typically exceeds 90%, with fertilized eggs developing rapidly in the warm water conditions. Quality control during egg collection involves microscopic examination to identify and remove any unfertilized or damaged eggs that could affect hatching success. The incubation process for cobia eggs takes place in specialized hatching tanks, equipped with gentle circulation systems that keep eggs suspended in the water column. These hatching systems maintain precise temperature and dissolved oxygen levels while providing gentle water movement that prevents eggs from settling and dying. The incubation period lasts approximately 20 hours at optimal temperature, after which the eggs hatch into tiny larvae. Newly hatched cobia larvae are among the smallest marine fish larvae produced in aquaculture, measuring less than 2 millimeters in length. These microscopic creatures survive on their yolk sacs for the first 3 days of life, during which they develop the ability to feed on external food sources. The larval rearing systems use greenwater culture techniques that maintain populations of beneficial algae and microorganisms that support larval development. The first feeding of cobia larvae represents one of the most critical phases in the entire production cycle. These tiny fish must be provided with appropriately sized live food that matches their microscopic mouth dimensions. The primary food source is enriched rotifers, microscopic animals that are cultured specifically for feeding marine fish larvae. The rotifer production systems operate around the clock to provide freshly harvested, nutritionally enhanced food for the developing larvae. Larval cobia grow with remarkable speed when provided optimal nutrition and environmental conditions. Within 10 days of hatching, the larvae have doubled in size and begin transitioning from rotifers to larger prey items like newly hatched brine shrimp. This transition period requires careful monitoring and gradual food size increases to ensure proper development and minimize mortality rates. The metamorphosis from larval to juvenile stage occurs approximately 25 days after hatching, marking a critical milestone in cobia development. During this transformation, the young fish develop their characteristic elongated body shape and begin exhibiting the aggressive feeding behavior that makes them such efficient converters of feed to flesh. Juvenile cobia at this stage measure approximately 1 inch in length and are ready for transfer to nursery systems. Nursery operations for juvenile cobia utilize sophisticated tank systems that provide protection while allowing for rapid growth and development. These nursery tanks range from 5,000 to 20,000 gallons and are equipped with advanced life support systems that maintain optimal water quality. The nursery phase typically lasts 8 to 12 weeks, during which juvenile cobia grow from 1 inch to approximately 6 inches in length. Feed management during the nursery phase involves a carefully orchestrated transition from live foods to formulated diets specifically designed for juvenile cobia. These specialty feeds contain high levels of marine proteins, essential fatty acids, and growth-promoting nutrients that support the rapid development characteristic of young cobia. The feeding frequency during nursery phase can be as high as 8 times per day to support maximum growth rates. Water quality management in Cobia nursery systems requires continuous monitoring and adjustment of multiple parameters including temperature, dissolved oxygen, ammonia, nitrite, and pH levels. Automated monitoring systems provide real-time data on water conditions, while backup systems ensure continuous life support even during equipment failures or power outages. The investment in water quality management systems can exceed $1 million for large-scale operations. The transition from nursery to grow-out facilities represents a major milestone in Cobia production, with juvenile fish being moved to massive grow-out systems capable of supporting rapid growth to market size. These grow-out facilities utilize some of the most advanced aquaculture technology available, including net pen systems in coastal waters and large recirculating systems on land-based facilities. Net pen operations for Cobia farming utilize specially designed pens that can withstand strong currents and storm conditions while providing optimal growing environments for the fish. These marine net pens typically measure 60 to 100 feet in diameter and extend 30 feet below the surface. Each pen can hold 20,000 to 50,000 juvenile cobia, providing the space needed for these active swimmers to develop properly. Land-based grow-out systems for cobia utilize massive recirculating aquaculture systems that can hold up to 500,000 gallons of water. These systems incorporate advanced biological filtration, protein removal, and water treatment technology that allows for intensive fish production with minimal environmental impact. The recirculating technology enables precise control of all environmental parameters while using over 95% less water than traditional flow-through systems. The feeding program for growing cobia represents a sophisticated blend of nutrition science and practical management. Commercial cobia feeds are formulated with premium marine ingredients including fish meal, fish oil, and specialized additives that promote rapid growth and optimal flesh quality. These feeds typically contain 50 to 60% protein and are designed to support growth rates that can exceed 4 ounces per day under optimal conditions. Automated feeding systems in modern cobia operations deliver precisely measured amounts of feed based on fish size, water temperature, and growth targets. These feeding systems can distribute thousands of pounds of feed per day across multiple grow-out units while maintaining accurate records of feed consumption and growth performance. The automation reduces labor costs while ensuring consistent feeding schedules that optimize growth and feed conversion efficiency. Growth monitoring in cobia operations involves regular sampling and weighing of fish to track performance and adjust feeding programs. Modern operations use underwater cameras and artificial intelligence systems that can automatically count fish and estimate their weights without the stress of physical handling. This technology provides continuous data on fish performance while minimizing disruption to the growing fish. Environmental enrichment in cobia grow-out systems includes structures that provide shelter and create more natural conditions for the fish. Research has shown that cobia perform better in environments that include artificial reefs, shade structures, and areas of varying water depth. These enrichment features reduce stress and aggression while promoting more natural swimming behaviors that contribute to better flesh quality. Disease prevention in cobia farming relies on sophisticated biosecurity protocols and health management programs that minimize the risk of pathogen introduction and spread. These programs include quarantine procedures for new fish, regular health monitoring, water treatment systems that eliminate pathogens, and vaccination programs that provide immunity against common diseases. The investment in disease prevention far exceeds the cost of treating sick fish and is essential for maintaining production reliability. When cobia reach harvest size of 8 to 12 pounds, the timing and method of harvest become critical factors in maintaining the premium quality that luxury markets demand. The harvest process typically begins during cooler, early morning hours when fish are less active and stress levels are minimized. Pre-harvest procedures include fasting the fish for 36 to 48 hours to ensure empty digestive systems and optimal flesh quality. The actual harvest of cobia requires specialized techniques developed specifically for this species due to their size, strength, and value. Unlike smaller fish species that can be harvested with nets, mature cobia must be handled individually to prevent damage and maintain product quality. Harvest crews use specially designed tools that allow them to quickly and humanely harvest fish while preserving the pristine condition that luxury markets demand. Immediate post-harvest handling involves rapid cooling using ice slurry systems that quickly reduce core body temperature to near freezing. This rapid cooling is essential for maintaining the firm texture and clean flavor that make cobia so valuable in premium markets. The cooling process uses a combination of flaked ice and chilled seawater that surrounds each fish and provides uniform temperature reduction. Transportation from farm to processing plant occurs in specialized refrigerated vehicles equipped with temperature monitoring and backup cooling systems. The journey from harvest to processing typically takes less than 6 hours, with continuous monitoring to ensure optimal temperature maintenance. During transport, fish are individually wrapped and cushioned to prevent any physical damage that could affect product quality or appearance. Upon arrival at the processing plant, each cobia undergoes rigorous quality inspection procedures that evaluate freshness, size, and overall condition. Quality control technicians examine fish for proper coloration, clear eyes, firm flesh, and absence of any defects that could affect market value. The inspection process includes both visual examination and physical testing to ensure that only premium quality fish proceed to main processing operations. The processing plant environment represents a pinnacle of food safety technology and hygiene standards designed specifically for high-value seafood products. Workers enter through multiple sanitization stations that include hand-washing systems, boot sanitizers, and full body wash stations. The processing floor maintains temperatures below 45 degrees Fahrenheit with positive air pressure systems that prevent contamination from external sources. Primary processing operations for cobia begin with precise scaling and cleaning procedures that prepare the fish for various market formats. The scaling process uses specialized equipment that removes scales while preserving the valuable skin, which is prized by chefs for its ability to crisp during cooking. Modern scaling machines utilize rotating brushes and high-pressure water systems that complete the scaling process without damaging the underlying flesh. The filleting process for cobia requires exceptional skill due to the fish's large size and complex bone structure. Master filleters can break down a 12-pound cobia in under 3 minutes while maximizing yield and maintaining restaurant-quality presentation. The filleting operation produces multiple products including whole fillets, portion-cut steaks, and specialty cuts like collar meat that command premium prices in Asian markets. Industrial machines used in cobia processing include automated skinning systems that can remove skin from fillets while maintaining maximum flesh yield. These machines use precisely calibrated blades and vacuum systems that hold fillets in position while removing skin in a single continuous operation. The skinning process requires constant adjustment and monitoring to accommodate the varying thickness of different portions of the fillet. Quality inspection continues throughout every stage of processing, with trained inspectors examining products for proper knife work, complete bone removal, and optimal appearance. Advanced inspection techniques include candling systems that use bright lights to reveal any remaining bones or defects that might not be visible under normal lighting conditions. Any products that fail to meet strict quality standards are diverted to secondary processing operations. Portioning operations for cobia utilize computerized cutting systems that analyze each fillet and determine optimal cutting patterns to maximize value while meeting customer specifications. These automated systems can produce portions ranging from 6 ounces for retail packages to 16-ounce portions for high-end restaurant service. The portioning process includes weight verification systems that ensure accuracy within 1/10 of an ounce. Value-added processing for cobia includes specialty preparations like marinated fillets, smoked products, and ready-to-cook portions that command premium prices in retail markets. These value-added operations require additional processing equipment, including vacuum tumblers for marination, smoking chambers, and specialized packaging systems that maintain product quality during extended shelf life periods. Packaging operations for processed cobia utilize state-of-the-art automated systems designed specifically for premium seafood products. Individual portions are placed on specially designed trays that provide protection during shipping while showcasing the product's visual appeal. The packaging process includes modified atmosphere packaging that replaces air with precisely controlled gas mixtures that extend shelf life while maintaining optimal color and texture. For whole fish products, individual cobia are wrapped in food-grade materials and placed in insulated containers that maintain temperature during distribution. Each package receives detailed labeling that includes processing date, weight, farm origin, and handling instructions. Advanced traceability systems allow customers to track their cobia from the specific tank where it was raised through every step of processing and distribution. Frozen product operations utilize individual quick freezing technology that exposes packaged products to temperatures of -30 degrees Fahrenheit using high-velocity air circulation. This rapid freezing process prevents ice crystal formation that could damage flesh texture while preserving the premium eating quality that justifies cobia's high market value. The freezing process typically takes less than 40 minutes for individual portions. Cold storage facilities at cobia processing plants maintain separate temperature zones for different products, with fresh items stored just above freezing and frozen products maintained at -10 degrees Fahrenheit. These storage systems include sophisticated monitoring and alarm systems that provide continuous oversight of temperature conditions. Emergency backup systems ensure continuous refrigeration even during extended power outages. Distribution networks for processed cobia span domestic and international markets, with specialized logistics systems that maintain temperature integrity from processing plant to final destination. Overnight delivery systems ensure that fresh cobia reaches restaurants within 24 hours of processing, while frozen products utilize established distribution channels that serve retail and food service customers nationwide. The premium nature of cobia requires specialized distribution partnerships with companies that understand the value and handling requirements of luxury seafood products. Distribution centers strategically located near major metropolitan areas provide rapid response capabilities for rush orders while maintaining inventory levels that ensure product availability for regular customers. Byproducts from cobia processing create valuable revenue streams that improve the overall economics of farming operations. Fish heads and frames are highly valued for making premium fish stock and are sold to specialty food manufacturers and high-end restaurants. The bones and processing waste are converted into high-quality fish meal that commands premium prices due to its excellent amino acid profile and digestibility. Cobia skin represents a particularly valuable byproduct that is processed into leather goods and specialty food products. The thick, durable skin is prized by leather craftsmen for making high-quality belts, wallets, and other accessories. In culinary applications, properly prepared cobia skin is considered a delicacy and commands premium prices in restaurants that specialize in nose-to-tail cooking. Fish oil extracted from cobia processing waste contains high levels of omega-3 fatty acids and is refined for use in premium nutritional supplements. The oil extraction process uses low-temperature methods that preserve the beneficial compounds while removing any impurities. This high-quality fish oil commands prices significantly above commodity fish oil due to its purity and nutritional profile. Collagen extracted from cobia bones and skin is processed into high-value products for cosmetic and pharmaceutical applications. The marine collagen market has grown rapidly as consumers seek alternatives to traditional bovine and porcine collagen sources. Cobia collagen is particularly valued for its bioavailability and lack of disease transmission risks associated with land animal sources. The culinary applications for farmed cobia have expanded rapidly as chefs discover its versatility and exceptional eating quality. The firm, white flesh holds up well to aggressive cooking methods like grilling and blackening while remaining moist and flavorful. High-end restaurants feature cobia in everything from classic preparations like pan-seared fillets to innovative applications in raw dishes like crudo and sashimi. Cobia's nutritional profile makes it particularly attractive to health-conscious consumers who are willing to pay premium prices for superior nutrition. A 6-ounce serving of cobia provides over 40 grams of high-quality protein while being relatively low in calories and saturated fat. The fish is an excellent source of selenium, vitamin B12, and phosphorus, while providing meaningful amounts of omega-3 fatty acids. The texture and flavor characteristics of cobia make it suitable for a wide range of culinary applications that extend beyond traditional fish preparations. The firm flesh can be cut into steaks that grill like beef, while the mild flavor makes it accessible to consumers who typically avoid fish. This versatility has helped drive demand growth in both restaurant and retail markets. Sustainability aspects of cobia aquaculture represent significant improvements over many traditional protein sources. both terrestrial and marine. Modern recirculating systems use minimal water while producing virtually no environmental discharge. Feed conversion ratios approaching 1.5 to 1 mean that cobia farming produces more protein output than input, making it one of the most efficient forms of animal protein production. The closed containment systems used in much of the cobia industry eliminate concerns about escapes and genetic pollution of wild populations. Unlike open net pen operations that can impact surrounding marine ecosystems, recirculating systems provide complete containment while allowing for precise environmental control. This technology addresses many of the environmental concerns associated with marine aquaculture. Energy efficiency in cobia farming continues to improve through adoption of renewable energy systems and waste heat recovery technology. Solar installations now power many facilities, while biogas systems capture energy from waste treatment processes. These renewable energy applications reduce the carbon footprint of farmed cobia while improving the economic sustainability of farming operations. Research and development efforts in cobia aquaculture focus on genetic improvement, nutritional advancement, and production system optimization. Selective breeding programs are developing strains with superior growth rates, disease resistance, and feed conversion efficiency. These genetic improvements promise to further reduce production costs while improving product quality and consistency. The integration of artificial intelligence and machine learning into cobia farming operations is transforming how facilities monitor and manage their production systems. Underwater cameras equipped with AI software can automatically monitor fish behavior, detect signs of disease or stress, and optimize feeding schedules based on real-time observations. This technology improves production efficiency while reducing labor requirements. Water quality monitoring in cobia facilities now includes real-time analysis of dozens of parameters using automated sensors and remote monitoring systems. These systems can predict and prevent water quality problems before they affect fish health while providing valuable data for optimizing production protocols. Machine learning algorithms analyze historical data to predict optimal harvest timing and market planning. The economic impact of cobia aquaculture extends throughout rural coastal communities, supporting jobs in farming, processing, transportation, and support services. The high-value nature of cobia production creates employment opportunities that pay significantly above average wages for rural areas. Economic impact studies suggest that each job in cobia aquaculture supports an additional 2.5 jobs in the broader economy. Export opportunities for American cobia continue to expand, particularly in Asian markets where the firm texture and mild flavor align well with consumer preferences. Premium cobia from American farms commands top prices in markets from Tokyo to Singapore, where consistent quality and food safety standards are highly valued. The export potential represents significant growth opportunities for the domestic industry. Training and workforce development have become critical success factors in the rapidly expanding cobia industry. Specialized training programs develop the technical skills needed for modern aquaculture operations, while universities offer degree programs in aquaculture science and technology. Industry associations provide certification programs that ensure workers meet the high standards required for premium seafood production. Food safety protocols in cobia farming and processing exceed requirements for most other protein sources, with comprehensive HACCP programs and regular third-party audits ensuring product safety throughout the supply chain. Traceability systems provide complete documentation from egg to consumer, allowing rapid response to any quality concerns while demonstrating the transparency that premium markets demand. The transformation of cobia from an unknown bycatch species to a luxury aquaculture product represents one of the most remarkable success stories in modern American agriculture. What began as university research projects has evolved into a sophisticated industry that produces millions of pounds of premium protein while supporting thousands of jobs in rural communities across the coastal United States. From the moment a cobia egg is fertilized in a controlled breeding facility to its final preparation in a world-class restaurant, every step represents the application of cutting-edge technology and scientific management. The precision breeding programs that produce superior genetics, the advanced grow-out systems that maximize efficiency, and the sophisticated processing facilities that maintain quality throughout the supply chain work together to deliver a product that consistently exceeds the expectations of the most demanding customers. The industrial scale and technological sophistication of modern cobia farming demonstrate how American agriculture continues to innovate and lead global markets. The combination of scientific research, technological advancement, and entrepreneurial vision has created an industry that not only meets growing demand for premium seafood, but does so while maintaining the highest standards of sustainability and food safety. Thank you for joining us on AgriCraft for this comprehensive exploration of cobia farming and processing technology. The next time you encounter this exceptional fish on a restaurant menu, you'll appreciate the remarkable journey of innovation and dedication that brought it to your plate. If you found this deep dive into advanced aquaculture as fascinating as we did, please give this video a thumbs up and subscribe to AgriCraft for more insights into cutting-edge American agriculture and food production. Share your thoughts in the comments about what agricultural innovation you'd like us to explore next, and we'll see you on the next episode of AgriCraft.